On air, okay. Buongiorno, good evening, everybody. Hello, Federico. Hello, Tomasz. I invite both of you to listen what you are talking, what you will talk about a new model of connection, people or materials. Because Tomek is much better in English than I, so I will concentrate on technical side of connection of the quality of our meeting. Later, there will be in Polish version. Tomek promised me to translate professional way just for Polish listener. So please, Tomek,
yes,
be not a guest, be a leader of this conversation, please. Now is your time.
The whole program is about the PRT system, which is not that well known around the world, neither in Poland nor in other places around the world. There are some systems that are already working, but they are sort of like working like prototypes. And what I would like to do is show the viewers, the listeners, what it is, what are the advantages, and what are the problems in implementation. And I would like you to Federico, to be able to talk about your side, your version of the big idea. So would you like to introduce yourself? I mean, or maybe say a few words how you came about getting interested in this kind of transportation systems. How long ago, and what was the thing that brought you into this idea?
Hello, everybody. So thank you very much for this opportunity to speak about our Relevo system. My name is Federico. I'm a mechanical and vehicle engineer from Italy. I studied in Bologna, Modena, and worked in Germany for a couple of years in the motorsport field as a design engineer. And the Relevo idea came into my mind after traveling every day with the train to the university, and then afterwards to my work. And so I've always thought about the thing that we have a very expensive and huge rail infrastructure, and then sometimes we go there and we cannot use it because there is no train. So we are bounded to schedules, and the infrastructure is so huge and we cannot use it when we want. So the Relevo idea came to solve this problem, basically. My first thought was how can a rail infrastructure be a non-stop, an on-demand, non-stop and personalized transport system for users. And from this question I made to myself, basically, I started to put on to design something that could make sense about it. So I designed, at the end of the day, a PRT system.
Mm-hmm. Maybe just for the listeners that don't know what we are talking about, is a PRT system is a system of vehicles that are about the size of a car, but use some dedicated way. Either it's the railway, but smaller than the typical railway, so much lighter, less expensive to build per 1 kilometer. Could be also road, but separated from the traffic. Could be suspended rail, and it could be also underground rail. So there are several systems that fulfill this criterion of PRT, personal rapid transit. But there are not that many built around the world, although the idea is pretty old and pretty obvious. But due to some economic constraints, due to some economic phenomena, that once we have chosen some road, some system, it's very difficult to switch to something different, because the infrastructure grew around something that maybe it's not economically optimal, but still it's simply it's been always there. Have you actually seen other systems of your, let's say, competitors? Although, actually the market is empty, so you can hardly talk about competitors. But have you compared your idea to ideas of some other people that did a similar thing?
Yeah, so you say the right things, because there have always been a transport system and their infrastructure, so they are already there. And for example, take rail. For example, is always we built the first rail in the 200 years ago, and then it's an evolution, always an evolution of an evolution. So it never happened a real revolution. If you want to implement a PRT system, that will be a revolution. So I think Relevo can be a system that can replace, in some part of Europe, for example, single track railways. And the reason is that our Relevo system, its infrastructure is so small that a double track line take the same width of a single track railway. So in the same space of a single track railway, we can build a double track Relevo system. That's the main point, at least for the European market, of Relevo. And in comparison to other PRT system, Relevo is not hanging on an infrastructure, is leaning on it. It's actually basically it's a rail vehicle. It's not a monorail. It's like Skytran or another company, Skyway, for example. So basically, we can actually convert the single track railway into double track Relevo lines. So this and another thing is that Relevo can reach speed that are quite remarkable. For example, we can a simple Relevo system can reach a speed of about 100 kilometers per hour, or on a high-speed Relevo system can reach 150 or also 160 kilometers per hour. And being on-demand, available 24/7 system and non-stop, also without intermediate stops, that will be very, very attractive to all of us. So and Relevo can also be a viable alternative to passenger cars. So in some scenarios, for example, where on rail only a tiny fraction of the people travel, and the other maybe 99% of the other travel on the road beside the rail, for example, we can attract a little bit of people that prefer to travel by car. That's the point. Considering that in Europe, which is the continent with more rail in the world, only 8% of the kilometer passengers are on rail and 92% are on tarmac.
But by the way, I was thinking, what do you think about the Relevo replacing a tram? Because we have a lot of congested cities in Poznan. So, for example, there is one tram line extension planned for the area that I live, but it's been planned for long time, some decades actually, but it's never been built because of constraints, financial constraints. What do you think about this kind of replacement? And important, what do you think would be better for your solution? It's sort of like a on ground, above ground, or underground? What do you think is the most recommended and desirable solution?
Okay, so tram system are not competitors of Relevo. So it's not Relevo is not a good solution for the problem that are solved usually by tram and buses. Relevo is more wants to solve the transportation problems that usually are solved by metro and regional trains. So it's about the first reason is that a Relevo line it's only for Relevo. It's an environment that is dedicated for the system. So Relevo comprises dedicated line and dedicated station and their vehicles. So that's why on a Relevo line cannot. So we don't even. It's not even allowed to make crossing because the traffic would be too much for a level crossing, and so that's why it's not good for tram. But it can be Relevo can be used to make a mini metro system, a metro with one station every 800 meters. With speed about 60 or 70 kilometers per hour. And in a city, this will be very, very optimal because we can go underground. We can do everything underground, line and stations, and with sections for the tunnel, which are 25% of the area, the section area, 25% compared to section area for a metro. So drastically reducing the material and the cost per kilometer.
By the way, what's interesting, what I found interesting in your system is the system of switching, which is vertical. So first of all, it's the type of switching which is connected with the vehicle, not with the track. What we usually imagine about systems like trams and trains is that these switches are connected with the rail. So when the tram or train needs to turn wherever. So the switch needs to change its setting, and then the tram or train can turn. In most PRT systems, usually the switches are somehow integrated in the vehicle. So the rail is fixed. You don't need to move it. It's always there. There is nothing mechanical or electrical connected to the rail. So there is no problem with servicing. There are no problems with breakdown. No problem with frozen switches like we have in Poland sometimes when we have very, very bad winter. But anyway, so your system has a very special type of switch because it's vertical. So normally in most kind of rail vehicles, when the switch is changed, the vehicle turns to the right or left. Yours is going up. Can you say a few words about it, because it's extremely interesting.
The Relevo vertical switch is, I believe, the main technical feature of the system. And as you say, a PRT system the switching mechanism must be in the vehicle. And this is also for Relevo is the same, applies the same rule. So basically, our Relevo vertical switch system, first of all, allowed for you can engage the switch, the vertical rail switch without decelerating the vehicle, so at the maximum speed. And you don't have any side acceleration, so there is no you have a better comfort for the passenger, and the vehicle is not destabilized because you don't have this bad lateral acceleration which destabilizes the vehicle. But the most important thing is that the configuration is in the vehicle. We design a special axle which has two configurations. One to stay in the main rail, so it's a cruise configuration, and a switch configuration. In the switch configuration, there are the extra wheels, switch wheels in the vehicle will open, and then will be configured and fixed and blocked. Sorry. And then so that the vehicle can engage the vertical rail switch. So another thing is that the vertical rail switch doesn't have any switch time. It doesn't have any movable part, and then it's compact. It doesn't have lateral footprint. It's perfect for the city because vertical space costs less usually. So it's a very, very good solution for a small rail vehicle. It's impossible to do something like that for a huge rail vehicle, but as our vehicle has the maximum weight of our vehicle with also payload, with also the maximum load inside, so the maximum payload is about 2 tons, so approximately 1 ton per axle, which is 20 times less than the maximum load that have usually trains. So this allows for this new solution to switch the vehicle from the main rail. So at the end of the day, on the main rail, vehicle are always traveling, never stops. It's like a car on a highway. You can't stop a car in the middle of the highway. You know, you go if you want to go away from the highway. In the same happen to Relevo from the main rail. You configure the wheels and you leave vertically. And then after it, you decelerate and you go to the station.
Yeah. I was thinking because of this switching system that it might be very good for the cities that sort of like want to replace, instead of building metro, instead of building underground rail, they want something lighter and much narrower. So you can have a instead of building the underground rail deeply underground, you do it shallow, just sort of a meter or something underground, and at every stop you just simply go up. So you did the rail level stops are sort of above the ground, on the ground level, and whenever your vehicle joins the traffic, it goes down into the trench or the tunnel. So was it thought like this? Was this idea actually behind your invention?
Yeah, this was one of the ideas, but the thing is that in the cities, in the first 2 meters is full of services, pipes, electricity, water. So it's not. It is actually better to stay a little bit deeper with the tunnel, so that where there is actually nothing that can be on the way. And then you can go up only in some points and have stations at the ground level, or maybe at -1 level. Yeah, that will be a very optimal solution.
Do you think, can it also work the opposite way around? Like, for example, that the main line is elevated but the station are below the main line. Can it also work the opposite way around?
Yes, it can, but it's not the optimal solution. It's you for the relevo design. The optimal will be to always to pass below the station, but it is possible actually. What you said.
I was wondering the problem with this of changing the system, of going into a parallel system, something between the car and the public transportation, traditional public transportation like buses, trams, trains. Do you think, how can you cross the border? How can you cross the gap? Do you think building some systems of relevo for cities that want to show it for the tourists, just as a kind of attraction, visual attraction for tourists? Do you think this could be an idea how to make people convinced that this system can work? How do you think about integrating it into traditional cities, the ones that especially in Italy, you have a lot of cities that are densely populated with architecture that is pretty dense, with very narrow streets. How do you think about integrating this together?
Yeah. So, for example, Rome. In Rome is full of history underground, so you are very constrained in building tunnel, because every 100 meters there is maybe there is a historical founding, and you have to stop the building the tunnels or everything. So with relevo, as the tunnel are much smaller, so you need to basically you need to remove much less material and take less space. You have you have less problems about that. So you can adapt the construction of the line much better in congested cities. And yeah, so this for sure. And generally, not only in Rome, but almost everywhere in Italy, we have space problem, and Relevo is tiny. Is actually tiny. So every dimension is cut by half. Relevo is basically like a 50% scaled train, actually. So the width is the 50%, the height is 50%. So it's a tiny system. So you can find space. You can fit the line much more easily in a city using a ground-based system, tunnel, trenches, or even suspended. And if you consider that a suspended structure is a structure for a vehicle that is 2 tons, it's like a car, it's not a train. So even the suspended infrastructure, it is much cheaper to build than a suspended infrastructure, for example, for a metro or a train. That's why we believe that there is a lot of market potential also in congested city, especially in congested cities for our system.
So, what is the turning radius? Because I suppose it's narrower than the tram. So for example, if you build it in the cities, let's suppose that it's all on elevated tracks. So you do not reduce any road surface for the cars. You do not reduce the surface for the pedestrians, for the bicycles. You add additional transportation infrastructure which is above the traffic. And what you mentioned, that it's lighter, it's actually lighter than the suspended than the elevated driveways for the cars, because they those can be also driven by big lorries, 40 tons, and your vehicle is only 2 tons, so it's certainly lighter. Do you think the way you would connect it to the ground? Do you think you need any special foundation, or can it be also a temporary foundation, like the foundation for that you actually turn like screws into the ground without using any concrete and without fixing it permanently? What do you think about structures that are sort of semi-permanent and built quickly above traffic?
So answering the first questions, the turn radius, the minimum turn radius is 80 meters. So it's not like a tram. Tram has less turn radius. So the reason is because as Relevo travel much faster than a tram, so we can also with our 80 kilometers per hour system, we can reach a maximum speed of about 100. Then reducing too much the turning radius then will make some problems with the wearing of wheels and rails. So the optimal minimum turning radius is 80 meters. So it's like the Swiss rails, narrow gauge Swiss rail is actually the same. About the infrastructure, we have already built a 200-meter test track for Relevo, and we used basically a metal structure bolted in on a concrete base, and so we can do. It's actually is kind of can be kind of temporary. I mean, it is bolted on the ground. This steel infrastructure, so it can be removed also. Actually, the infrastructure we built in Italy can be, we can remove it completely, put it on a truck and build it somewhere else. So actually is movable. So it's a light infrastructure, and it's easy to build. It's very versatile actually.
There are some cities that build the suspended the ropeways as for cities as an additional line of transportation. I think they are doing it in Paris and even in Gdańsk, I suppose, in Poland. They are planning to build it. Just go above traffic, above the trees, above the roofs. Do you think going that high with Relevo would make sense as well? Would it be competitive towards the ropeways, or is it a completely different type of completely different type of idea, sort of? Because normally the ropeway, of course, is used in the mountains because you have to change the elevation. You go from the bottom to the mountains, and sometimes you want to cross above the landscape and go a pretty high, go on heights and sort of it's a tourist attraction because from the height you can see a lot of scenery. Do you think that the Relevo could do something similar, or it's not really this type of system that could replace the ropeway?
Excuse me. Can you hear me well?
Yes. Yeah.
I lost. So your question is if Relevo can have a similar, can be competitive with some
ropeways,
system, or.
Yes. Like, of course, not in the mountains because probably the elevation. Because that's another question. What is about the difference in elevation? Can it go steep up and steep down? How is it?
Relevo, the Relevo vehicle is based on 3 different systems. One is the axle, the configurable axle with the switch wheels. We can have 2 position, cruise and switch configuration. The mecanum wheels that are used at the station, so that at the station the vehicle becomes AGVs, so that can move omnidirectionally, and once the vehicles reach the station, the vehicle will leave the rail and go away from the traffic, so that the station is always available for the vehicle behind, creating a continuous flux of vehicles. And then the third subsystem is the high adherence system. Is a system that allows the vehicle to have a very, very high grip on rails. So we can, this allows for very powerful deceleration. In the worst case scenario, the maximum deceleration is 1G. So it's better than that of a car. And this allows also for very high gradient, up to 20%. So it's the gradient is not more, because otherwise it's a matter of power needed from the vehicle, and also it's only because of that, and also speed. So we can have a very steep rail, but then we have to reduce a lot the speed. So only very tiny segment can have a very high steep gradient. But this is allowed. This is possible with Relevo, and so Relevo can be used also in mountains.
Please finish your.
In mountains, and then we in the sail. The cable systems.
Yes, cable car.
Cable car are they solved a different problem. So they can, the market is not exactly the same, but there are some maybe some tiny overlapping of the market. So in some special market, we can also be competitive with some cable cars. We have a huge advantage compared to cable cars, that cable cars, you have to operate the complete system to make it operative also for one person. In our case is a PRT, so the system can be still and only one vehicle can move around. So it's very, very versatile for that. Relevo can be operative for 2 people a day, or 5,000, or maybe 50,000 people a day. And that's the difference. A sail car is it's not worth to operate for if there is not enough users. And also another thing is about the operating cost. We have very, very low operating cost. So it's I believe is the minimum compared to cars, trains, cable cars, and that make Relevo the most affordable travel solution ever that can exist, for 2 reasons. One is that we have a tiny and passive infrastructure and very affordable infrastructure. And the second is because the maintenance of our vehicle, the operating cost of the vehicle is extremely low. And also, it's also a rail system, so it's very, very efficient. It's about 4 times more efficient than the best electric car on the market.
I have 2 questions, 2 things. Do you have any pictures with you, maybe Tomek or Federico? Because we are talking about the things RTV, which is sounds fantastic, but will be great to see, even a prototype. Do you have
Yes.
such a picture?
I can, if you like, I can.
Yes, you can try to share it. There is a function. I haven't used it in this environment, but I suppose.
Is it down below the screen with the
yes.
Yeah.
Yes. Okay. Yes.
This is the first, and the second is that I found your idea very competitive for taxi driver. For sure, they will hate your idea because they are very, very expensive and arrogant many times.
The taxi drivers, yes.
Yeah.
Yes.
When,
Can you
yes, I
see
have
it?
it.
Yes,
So-
we can see it.
So this is our Ray-Levo prototype. The Ray-Levo concept.
That's great.
The benefits on demand 24/7. This is the vertical rail switch.
Uh-huh.
I can show you also a video of our prototype engaging the vertical rail switch.
Uh-huh.
Let me check if I have some. So this is another picture of the vehicle with the dimension is a 6.5 meters long. The empty weight is about 1,300 kilos. It has a battery which is a LFP 15 kilowatts per hour. And
Yes.
That's
the
great.
efficiency-
This was one of the things that I wanted to ask you. Yes. So does it actually recharge? Do you recharge the battery while you're driving, or you recharge it at the stations?
No, we usually recharge at the station, but in future we can also implement induction recharging while traveling. But it's it's not for now.
I
We
see.
will maybe do it in so this is the systems in the vehicle. So we have this double configurable axle for engaging the vertical rail switch or cruising. Then we have the high adherence system, which are these vertical axis rubber wheel that are engaged on the side of the rail only if needed. So they are usually not working. It's like the landing gear of an airplane. You use it only when you are on the ground, basically.
Ah, yeah. Mhm.
There are the mecanum wheels. The mecanum wheels are used at stations. I can also show you, for example, this is how Ray-Levo, it can be used for disabled people, families and group. You can use it alone, or also for cargo. You can transport 2 Euro pallets on it, up to 700 kilos payload. Then this is the dimension of the infrastructure compared to a metro system. And so this so this is you can see that we have 95% weight on the rails and 50% less space in each dimension. So basically it's 70% less space actually.
Yes. It's interesting. Yeah, the thing about the narrow tunnels is very interesting because nowadays in Poland we are sort of thinking about not only the environmental, social, and economic aspects of the transportation system, but also defense and defense of cities actually requires building tunnels, and the tunnels are expensive. The tunnels are the bigger the tunnels, the more expensive they are. And if you can do something with narrow tunnels rather than big tunnels, then you can provide some transportation system that doubles as a shelter as well. This is one of the reasons that I think about sort of ultralight rail and built underground as a viable development for the cities.
It
And
is,
Tomek,
yes.
Tomek,
Yes.
I think the main problem for Polish citizens living outside the big cities is just transportation, achieve the working place every day. And they use, many times, they use their own car. And will be great to use your idea to help such people who will achieve the, how to say,
Mobility.
state. Yeah, and just they will come from the 30 kilometer from Poznan just to achieve the round trail and or metro, which is not existing in Poznan still. But you understand, it will help to
Yeah.
achieve the working place.
Yeah.
Very,
Yeah.
and cheaper, of course.
Yes. Well, the main thing about a PRT in general is that it's quicker than the car, quicker than the tram. So if you think about the tram going from the opposite ends of Poznan, like for example from Unikowo to Miłostowo, if you calculate the average speed, it's 20 kilometers per hour, because the tram needs to stop not only at the tram stops, but also at the crossroads.
Exactly.
And between the trams themselves, the tram can have 300 people in one vehicle, but there'll be a few kilometers distance between the vehicles. So instead of having 3 kilometers of empty track between the vehicles, it's much better to have a lighter, narrower, cheaper, less expensive track with vehicles in much shorter distances and going all the time with the same speed and covering this distance in 1/3, 1/4 of the time. So there's an economic value because the most expensive thing about public transportation is the time of the traveler. Usually the city planners think only about their own costs, the cost of the city, that building the tracks, building the vehicles, driving the vehicles, powering the vehicles, and so on. But they never think about the cost of the person that is sitting in this tram and spending half of the, well, I mean, not half of the life, but 2 hours per day in the traffic. So if you can remove the aspect, the stops of any kind, going with the speed of 60 kilometers per hour only, you travel 3 times quicker.
Exactly. Federico, we lost you.
Some problems with the connection.
Yeah,
No,
now I can
you
hear
are back.
again.
You are back.
Yes.
I lost you for I lost the last 20-30 seconds.
Yes, we were talking about the average speed of trams in the city. That it's about 20 kilometers per hour if you consider the tram stops and the crossroads. So when you replace the trams with the PRT system, you actually even if you don't go at the speed of more than 60 kilometers per hour, you still are 3 times quicker than the tram. And you're saving the time of the travelers, which is actually the most expensive part of the transportation, never counted by the city planners, but it is expensive.
For example, we are studying, we did some studies about the conversion of a 60 kilometers infrastructure in Italy, which is quite used in this moment. Actually, 83 million people, users per year, travelers per year. So it's about 8,000 people journeys per day. And so we calculated that with Relevo we can travel the same distance in 40 minutes instead of 1 hour and 50 minutes. So
Exactly.
basically 60% less. So if you consider that how many hours of life hours we can save, and if you can usually they every passenger hour is considered to cost 20 euros in Italy, but it's not very, the raw costs are more the decision makers are actually more sensitive to building to OPEX, to CAPEX and OPEX, not about these costs. But so we can basically save 3 million hours of life hours every year with Relevo compared to the train. In a very simple infrastructure, is a 60-kilometer single track railways between the mountains in the Alps. It's not. We can applying Relevo or a PRT system in a city would save a lot of life hours and make people happier and improve life quality everywhere, because I believe transport is one of the main thing that makes that improve life quality in a city.
Well,
I'm happy.
Also metro are considering that are stopping every few minutes. The commercial speed is so low, sometimes 35 kilometers per hour, 40 kilometers per hour. Yeah, sorry, go ahead.
Tomek?
Yes, I was thinking about use cases for the person with disabilities. You did I suppose you have mentioned the persons with disabilities, well, like people on wheelchairs, but I'm thinking about people with mental disabilities, like for example with people with Alzheimer, which are sort of like slow, and they find it difficult to navigate a complicated system of changing buses, changing trams, changing vehicles, and things like sending children to school, for example. Nowadays, most Polish parents take their children to school by car. So the parent goes with a child to school just to drop the child at the school, and then takes the same distance back. So, do you think a PRT system could replace the people that assist either the elderly, either the person with mental disabilities, either the children, just to allow the persons which are not completely self-sufficient to go to the places where they need to go, being only let's say assisted from remotely by their caretakers, like for example an elderly person going to a hospital, or just replacing taxi in such a situation.
Yes, so every logistic with Relevo is easier than the logistic used in trains or cars, because with Relevo I don't know other PRT system, but with Relevo, for example, you can board the vehicle at the station, taking your own time. So it's if it's an elderly people, or a disabled or a person with Alzheimer, they can take their time to board the vehicle. So they can take also 15 minutes, their time, it's a taxi actually. So, and when they are ready, they can also communicate verbally inside to say that they are ready, and then the system tell them that the door is closed and that we are ready for departure. Then the vehicle will go autonomously to the accelerating line, will accelerate into the main line, and then if a vehicle have to switch from one line to another line, that this can be made. For example, when two line crosses, in every crossing there is a node station, so that if you want to switch from one line to the other, you just have to, the vehicle does it. It's not you that it's autonomous. The vehicle does it autonomously. So it will leave the first line, goes into the node station, and then will get in the second line until the destination. So and then it's also much safer, because there is no contact. It's impossible for a passenger to stay close to the rail, because rail is they are below the station, they are not at the station. So it's impossible to have a fatal accident inside the station, because inside the station vehicles moves on mechanism wheels at about 5 kilometers per hour. So it's a 2 tons vehicle that move at 5 kilometers per hour. It's not a 200 tons train that travels at 80 kilometers per hour, 1 meters close to the people, to the passenger, which is, if you think about it, how dangerous is a station, which it's very impressive that, but we are used to it, So if you want to send your kids, for example, you can bring them to the first Relevo station, and then send them with a Relevo vehicle to the other part of the city, and then somebody can
pick up,
can take them from the other side of the city in a private environment, safe. You can communicate with them. I mean, it's. I believe it's much better than what we are used to in a metro station, that you can encounter every kind of people. And then, every person that travels in a Relevo vehicle is kind of, the system knows who is traveling. So you have to behave, basically, because otherwise you can, can be, you cannot, otherwise you will face some problem. So, same for elderly people or kids, or even cargo. You can.
Yes.
You can send €1 pallet from one station to another station. Of course, some station can have a special area for cargo, or there can be specialized station only for cargo in the same line, or a mixed station, and so that this makes very interesting.
Yes.
This will improve a lot the user experience compared to trains and metro.
for sure.
Yeah. Well, I think we are sort of approaching 1 hour, and we are planning for 1 hour, and I think we have discussed about every most important aspect of your system. So I think we can close it. at the moment, see how the how this video reaches the listeners and viewers. And if they have some questions later on, we can always repeat it and answer specific questions.
Okay.
This is
I'm always available to, to answer questions in case. Yeah.
It's a big experiment from our side. We had, as I mentioned before, in our telephone conversation, we had only one similar conversation before with Robert from United States that produced a PRT system for cargo for 10 kilogram packages. So
yeah.
Yours is. You are the second person that we are interviewing this is the full scale PRT, and well, let's see how it develops. I hope we'll get some people interested in it and see more developments. Hopefully also for you, because your system is pretty interesting in comparison to the others, and hopefully it finds some use cases around the world.
And let me say my impression, please. I'm very happy to meet somebody who is going to make people happy. It's you. It's really nice to meet you and to listen your idea. And I really believe there will be somebody who will take care about this idea and will help us to see such a very sophisticated system in Poznan, for example. Thank you, Tomek, for this your invention. Thank you, Federico, for such a long explanation and details and the pictures, of course, and really interesting discuss. Thank you very much, Federico.
Thank you too. Thank you for inviting me and have the opportunity to talk about Relevo. It was very nice talking with you. And
thank you very much.
If you will be at InnoTrans in September, we will be there in Berlin.
Berlin. Oh, okay.
Not far from us.
Yeah, exactly. That's why.
It's very
and
easy.
if you come to Trento, to Italy, to see the Relevo prototype on its rail track, then you are invited.
Thank you. It really sounds interesting. So I must say till next time.
Yes.
Okay. Yeah. Thank you again.
Thank you.
And, see you soon. Bye bye.
Bye bye. Thanks.
It will take few seconds when I switch